Thank you. Yeah, as already mentioned, my name is Tim, and I would like to tell you something about scaling Puppetserver for multiple thousands of clients, including probably all or at least most of the pitfalls that you can run into. Short introduction, I go by BusterFreak on the internet. You can find a very active GitHub account under this name, also Twitter if you're interested. I'm active in Puppet since around 2012, and I'm active in the community and merging stuff since around 2015, and I'm one of the Vox Populi project management committee members. So imagine the following setup. You're Googling around, you think config management is quite cool, you would like to introduce it into the company, and you find something that's called Puppet, you install it. In a very small proof of concept environment, you have this single server, this is the original size, one box, and you install Puppetserver on it. And you are quite happy with it, it seems to work, you have some local virtual machines, you install the Puppet agent, everything seems to work. And next day, you come to work again, your coworker said, hey, I saw that you installed Puppetserver and I have this small production environment with like 500 clients. I needed to roll out new SSH keys for a new employee, and I just connected all the production environment to your Puppetserver. That's probably fine, right? No, absolutely not. Like, that's a proof of concept. Why did you do this? Okay. Now the setup went live. Congratulations. Sometime later, you notice like the agent, they produce reports. They also have catalogs. It would be nice to store it in the database. So you install PuppetDB on the same box. And you notice PuppetDB has the words DB in its name, but it's not an actual database. So you install Postgres as well, because you need to store the data somewhere. PuppetDB is just an API. Now you have a big database, it's growing, everything seems to be fine. But you're wondering, well, I have a database, so it would be nice to have a dashboard for the database, so you install PuppetBoard, which is very nice. It's a read-only front end for your data. And sometime later, you are still thinking about it. It would be cool to also have a front end where I could configure stuff, so I could write to a database. And also it would be helpful to have dashboards that say everything is red or green, that you can show to your line manager, so you have a proof that you're actually working or working not. So you install Foreman. Still, everything on this single box. The box gets quite hot, but it seems to work somehow. This whole process takes a few months. People are adding more and more agents to it. Next day you come to work. Your coworkers say, hey, we heard there is this cool new thing called orchestration, and we rolled out Salt and Ansible. It's like, what the hell, why stop this? There is a solution for this. We could just use mcollective, or no, now it's called Chorea. For Chorea, you need a messaging daemon, so you install nuts as well. And now your box is on fire completely. Again, next day you come to work, and your coworker's like, hey, could you check the monitoring, please? All my agents are red. Like, what kind of monitoring are you talking about? There is no monitoring on this list. Nobody ever requested monitoring, so everything is now broken and dead. And that's the point where you start to think about, well, how could we actually implement a proper architecture that scales and provides everything that we need? I was at this point like 1 or 1.5 years ago, and containers started to come up, and I was thinking like, it might be a good idea to deploy every service that we have in a container, and so we could properly scale out, maybe on a fancy Kubernetes setup. And I'm a DevOps engineer. I try to be a good engineer. So what does a good engineer do? What does a good engineer do? You open up Google, say how to scale Puppetserver the fancy way, and you find something like this. Like that's just too many errors. We can't do this in 1 week, or at least, yeah, no. That takes too much time. We need to take a different approach, absolutely. So the setup that we went with in the beginning was quite simple. We built a fancy cloud, which contained only 4 physical servers. A very small one that only contained the Puppet CA, because that just doesn't do very much stuff. We already figured out that Puppetserver uses quite a lot of CPU resources, so we put a big box up for the Puppetserver and another big box for PuppetDB and Foreman, and something with very fast storage for Postgres database. That's something that we can work with, and after that we started to checking different services and trying to implement some improvements. And I would like to present you a small walkthrough now. So let's start with Puppetserver. The most resources used by Puppetserver is the JVM. Within the JVM, there are several JRuby processes, and they compile mostly catalogs for all the agents that request a new catalog. Normally, a JRuby can compile 1 catalog at a time, so if you have more JRuby instances, you get more catalogs at a time. Quite easy to calculate. Since Puppetserver is installed on a single box, we can just tell it to use all the available logical cores that we have. We use the Puppet module from the Foreman people to manage not the Puppet agent, but also the Puppetserver itself. And with this fancy hierarchy, you are very easy to tell it to use all the available cores. The default is something around 2 JRuby instances, or 4, I think. So if you use a very beefy box with 24 or 48 logical cores, you get quite some performance boost just with this simple setting. So next step. Still, you get more catalogs, but still the whole setup feels quite slow, and there are still agents that are failing. So we were checking for more improvements that we could do. As it turns out, the Puppetserver normally gets a request to compile a catalog. Afterwards, it loads all the Puppet content from an environment into the memory, compiles the actual catalog, returns it to the agent. Afterwards, flushes the whole cache. The next request comes in, it loads the data again, which is not really necessary. So you can tell the Puppetserver to keep all the Puppet data in the memory, which reduces a bit the compile time, which is nice. On the negative side, you need to take care of purging the cache now. There is a fancy API call for this. Here's my mouse. So there's an internal API that you can call to purge the whole cache. You can add a parameter to purge only the cache for a very specific environment. You don't need to provide the parameter. In that case, every cache that you have will just be dropped. And you could implement this as a post-hook command to your RTK deploy or whatever you do to deploy new code to production or whatever branch you are working on. The setup was now, it was working quite good, still not perfect, but a coworker mentioned that from time to time, his agents just die, or they take an hour to run, and the rest of the day, they only need a few seconds, like 20 or 30 seconds, because they don't apply any changes at all. They just run through and tell you that everything is fine. But just sometimes, they simply die. And yeah, our first statement was, no, that's not possible, you're doing it wrong. As it turns out, no, there was some issues. We noticed that the Puppet module that we use to manage the Puppetserver by default creates 2 empty environments called development and production. In our internal control repo, we have several branches. Our production branch was back then named Puppet 4, not production and also not development. And every time we do an RTK deploy for the environment, it purges empty environments that are unknown to the Git repository. So The Puppet agent run, created, development, and production, R10K range, throws them away. Next time, the Puppet agent run again on the Puppet server, creates the environments again, and every time the environment is created by Puppet agent, it also restarts the Puppet server, which sometimes takes 5 to 10 minutes. So every time a Puppet agent run, we restarted the Puppet server service by accident. That was quite annoying. This took us a few weeks to figure out, but it's quite easy to fix. You can tell the module to don't create any branches or to don't create any empty environments. Next thing that was quite important is memory tuning. The JVM allocates a huge amount of memory, and that's shared across all JRuby instances. So every time you increase the amount of JRuby instances, you should increase the amount of memory that the JVM can allocate. The official Puppet docs recommend that the amount of minimal allocated memory and maximum allocated memory is equal. And they are quoting the official Oracle Java documentation. But as it turned out, this statement from Oracle is only very specific for Java 6, which isn't, hopefully, it's not used anywhere. Hopefully, nobody knows. Yeah, but the statement is gone for Java 8 and Java 11. And we did some internal testing, and we didn't see any performance improvement when the amount of minimum and maximum memory is equal. So we configured our Puppet server to allocate less memory and in the beginning, and it was allowed to use more memory after some time. Because what you need to keep in mind is if you have a huge amount of memory, like 128 gigabytes or 256 gigabytes of memory that you can give the JVM, it might use more than 10 minutes to start up and to allocate all the memory. But it's not only allocating the memory, it's loading a lot of contexts, and it's loading all the Puppet code, and it's doing this for every JRuby instance. So this takes a lot of time, and yeah, we noticed that we could lower the startup time by just setting a very small amount of minimal memory. So now, Puppetserver was running quite good for us, which was bad because it killed our Foreman installation. So we had to take a look at Foreman and try to figure out how we could improve the performance here. Foreman has built-in support for using memcached as an object, as an in-memory object store to cache some data, which is a very good performance improvement. It's not a requirement to give it 50 gigabytes of memory. We just had a box that was too big, so we said just take all the memory that's left and be happy with it. We did some tests, and in our case, with around 3,000 agents, 4 to 8 gigabytes of memory is totally fine for the setup. You can probably go with even less. And if you ever want to run highly available Foreman, the memcached is also a requirement from the Foreman people. Yeah, and as you can see, it's quite easy to configure. Just 2 lines of Puppet code and 3 lines of Hira code. And afterwards, Foreman is slightly faster. But still, we figured out it's not fast enough. So I thought I would like to be a good engineer still, so I was Googling how to improve Foreman the fancy way. I clicked the second Google link, and as it turns out, there is a fancy command line tool called passenger status. And it lists many nice information, for example, the amount of requests that passenger received, the amount of threads it started up, and the amount of requests that each thread got, yeah, fancy stuff like this. And as it turned out, by default, it only starts 2 threads, which is not very much. Again, this is very easy to configure with just 2 lines of Hira code. Yeah, and if anybody didn't know, Passenger is the used web server from Foreman to execute all the Ruby backend code. Yeah. We told Passenger to allocate as many threads as we have logical cores, and also do this directly after startup, because the startup here is way, way faster than on the Puppetserver side. So this wasn't a negative thing, and it works quite well. In fact, it worked so good that it killed the database connections. So now Foreman basically killed itself because it had too many threads, but by default only 5 allowed database connections, or 5 concurrent database connections. So that's something as well that we had to improve. Interesting fact is, at the moment, Foreman in our environment has 48 threads that it starts, but it works quite well with only 20 concurrent database connections. So there seems to be no situation where each thread is actually active and wants to access the database. So the database pool doesn't need to be as big as the amount of threads that Passenger or Foreman gets. Next thing that we improved was Keep Alive. This is enabled by default already, so HTTP Keep Alive connections. This means that Foreman won't close an HTTP connection after everything is finished. It will keep it open, but by default only for 5 seconds or 100 requests within one TCP connection. And we increased this to 3 minutes or 1,000 connections, which also lowered the amount of overhead that we have for each connection, and it was a very good improvement. Improvements, again, are very bad because this time it killed our database. So yeah, just too much traffic or too many concurrent requests. Postgres is a bit complicated. There are so many things that you can improve and configure. If you would really like to improve or really understand how Postgres is working, I highly suggest that you attend at least the FOSDEM Dev Room that they have each year, or the Postgres conference. That's quite good. Besides that, they also have a very active ISC channel where you can get a lot of information that helped me as a starting point. Also, you should use Postgres 10 as your backend for PuppetDB and for Foreman, because Postgres 10 allows multi-threaded SQL queries, which is very, very nice and heavily reduces the amount of time a single query needs if you have a lot of cores. And also, you should consider buying very fast storage. We have a shared Postgres server where multiple databases are running on, and normal SSDs or SATA SSDs weren't able to provide us the load that we would like to put on the box, so we went with NVMe SSDs, and that turns out quite well. And the setup now makes something like 12 gigabytes per second storage read. That's nice and fast. I can highly recommend. Also, pgtune is a very nice tool. It can read runtime information from the Postgres server and also the use configuration file, and it will output an optimized version. And all the optimized keys that it gives you, you can implement with the Puppet module to just write it to your Postgres file. And please don't use maximum connections of 400. This is in 99% of the cases way too much and will kill your Postgres database. Don't do this in production. That's not good. Okay. After Postgres was working better, we noticed that the physical box where the Puppetserver is running on isn't running at high load, but this is the system that requires the most amount of CPU time. And still, our Puppet agents were very, very slow. They took several minutes to just apply a catalog with 0 changes. So we were digging around, and we noticed that PuppetDB was the root cause in our case for being slow. Yeah. Again, PuppetDB is running in a JVM, just like Puppetserver. So you have options to increase the minimum and maximum amount of memory that it uses. It also has a built-in dashboard that you can access via HTTP, and it tells you the amount of used memory. And yeah, you can just monitor the dashboard for a few hours or a few days and see the amount of used memory. Afterwards, increase the amount of maximum that it should allocate. And that was a huge performance improvement for us. Also, we have those three settings available. We purge dead nodes after 14 days automatically from the PuppetDB if the ops guys forgot to do this after deprovisioning a server to call the PuppetDB API to purge those by hand. And also, we are storing reports for 999 days, which is, I think, the maximum. Again, most of the people don't need this because nobody looks at the reports, but we wanted a realistic benchmark for the PuppetDB and also for the Postgres server. So we try to keep as many reports as possible so we could grow the database and see how the load changes on both systems. And this is still working quite good, but nobody reads the reports. They are just sitting in the database. Yeah. Also, PuppetDB, you can configure the amount of maximal threads that it will start for everything. Default is 50. We have a quite beefy box. So we said, let's just try to give it 100 threads. This works quite well. Very important setting is the one at the bottom, concurrent writes. This is the amount of database writes that it does. And we noticed that everything that's higher than 8 will probably kill our Postgres database again, no matter how we configure Postgres. So 8 is working out quite good, and the system seems to be fast enough. And important is the DLO was dead letter report cleanup. If you set this to true, you will get a systemd timer or a cron job to purge very old error reports from PuppetDB. We didn't know that those reports actually exist, and I think by default they get purged if they are older than 14 days. And they just filled up our local storage, and nobody checked the error logs. So yeah, there is an option to automatically purge them. Now we're at a state where the whole setup seems to work quite fine. We identified that those 4 services consume the most amount of storage I/O or CPU power. And everything seemed to work very fine. The agent took only 22 to 30 seconds on most of the systems if they didn't apply any changes. And that worked very good for half a year maybe. And afterwards, again, we saw that agents are running into timeouts and that the single Puppet server just hadn't enough CPU power to handle all the requests. And back then we had 3,200 agents, I think, with an average of 800 resources per node. And their agent run every hour, I think, so quite often. And they produced a huge amount of load. So we were thinking about how we could scale the Puppet server even more. So how could we do a scale out? And we went with a very, very simple approach. So what we wanted to do is just add an infinite number of new Puppet servers to spread the load across them. But with one constraint, we didn't want to use a load balancer, because that would mean that we need to terminate TLS connections on the load balancer and hand out our TLS private keys to the load balancer, which is something we didn't want to go. And also, I'm not a big fan of proprietary load balancers, and we were too lazy to set up our own stuff with HA proxy or Nginx. So we were thinking about this, and while we were thinking about it, we took a look at the web server, which is in Puppetserver. That's a library called Trapper Keeper Jetty 9. And this is 2 quotes from the official documentation. There are several settings that you can tune. One of them is named Selector Frets, which is basically the amount of HTTP connections that the Puppet server can accept at one time. And those threads, after they finish dealing with opening the connection, they are handing them over to another pool of threads. So selector threads are only necessary for handling the initial connection. And very important, there is no known upper limit for selector threads. You can basically start as many as you want. Very interesting for the SSL selector threads, which are used by default because by default Puppetserver speaks HTTPS. Defaults to the number of virtual cores on the host divided by 2 with a minimum of 1 and a maximum of 4. What? Like, why? Why is there an upper limit of 4? Why can the Puppetserver only accept 4 concurrent HTTPS connections and hand them over? That's just not enough. That's very annoying. So I know that especially the guys at Puppet Labs that work on the Clojure backend and on Puppetserver are very, very smart. So I assume that there is a very good reason for this upper limit of 4, but it's just not written down. And nobody could tell me why there is this limit. Very, very annoying. Okay, so the way that we went is to install Nginx on each Puppetserver box to terminate the TLS connections. And Puppetserver is only listening on localhost with an HTTP backend. So now it's accepting basically an infinite number of connections. And even if the Puppetserver is overloaded, Nginx can still cache the connections, keep them open, and check if Puppetserver has free slots available. And after this, forward the connection to Puppetserver. The Puppet code needed to configure this is quite huge. It didn't fit on a single slide, sorry. But you can check out the example control repo that I have. And it's implemented for like 98%. We have this running in production. This works fine. I need a few more days to port this over to GitHub and to open source it. But this is working quite good. And for load balancing, we went with a very small console cluster with 5 virtual machines spread across the data centers that we have. And console provides us very nice service discovery and service registration. So on each Puppetserver box, there runs the console as an agent with a local script that just polls the internal Puppetserver API to check if it's still working. If that's the case, the service gets registered to console, and you can access Puppetserver via console. And in case the load is too high on Puppetserver, console will purge the service again from the DNS load balancing. This is very, very nice. Console by default has a TTL of 0, so records are not cached at all. So if one of the servers goes down for maintenance or has too much load on it, it's immediately not available anymore for more requests. And yeah, this is a setup that works quite well for us. We have this in production since 3 months now, I think. Yeah, with 0 issues. And every time somebody discovers a new production environment with some 100 nodes that he would like to add, it's like, oh, I found a new data center or a new room or something like this, which might happen from time to time. We just add a new Puppetserver to the to our setup, and yeah, that scales quite good. After this was finally working, we started to figure out now we should finally implement monitoring and metrics, which is probably not the way that I recommend. Normal people should start with metrics first and afterwards improve their setup. But yeah, that's the way we went. By default, Puppetserver can expose graphite metrics. We didn't have a graphite stack available in our company, and I was checking the Puppet Forge to find a suitable module to set up the whole graphite stack. I didn't find any module that fulfilled my needs, and they looked just quite outdated or didn't run on the desired operating system. So we just throw the idea away and checked for other solutions that we could go with. There is a nice protocol called JMX, which exposes a huge amount of metrics. This is built into Java or into the JVM, and Puppetserver exposes those metrics via a wrapper library called Yolokia. This is nice, and you can pull the data via HTTP, but it's quite slow. This is nice if you have single checks, for example, for console or for your monitoring with Isinger, but it's probably not desired to pull every metric that is available. So again, we were checking for other solutions. I already had a Prometheus database available. So I was checking if this would somehow be possible, and in fact it is. The Prometheus people have an official JMX exporter. This is probably their only project that's not written in Go, but in Java. It's just a jar file that you can download, and you add it to your Puppetserver JVM options, and it will by default expose a Prometheus endpoint on localhost on port 9020. We did this, we restarted Puppetserver, I did a local curl command to pull the metrics, and after a few minutes I got 55,000 lines, I think, on the endpoint. It should be by default, each metric has 2 lines of comment in it, so there are still a very, very huge amount of metrics available directly. And not only the default JMX data, like the amount of used memory or the amount of used CPU resources, but also Puppetserver internal stuff. And something else that we learned is that also PuppetDB supports the same setup to export metrics, also quite nice. The Puppetserver caches metrics for each agent that it has in each environment for each function that it called. And for each metric, you get 4 to 5 different values. So the more agents are hitting the Puppetserver, the more metrics you're receiving. So after 2 hours, we got 750,000 lines from one Prometheus endpoint. And if you use like 3 call statements at a time to pull this data, the whole JVM dies and Puppetserver isn't responsible anymore. And you had to restart the whole box. Okay? Doesn't work quite good. It seems to work well when you only pull once a minute, and also you can configure within the Puppetserver and also within the exporter which metrics you would like to have, and you can blacklist those that you simply don't care about or the ones that you don't know, which was, in my case, the majority. We have some fancy dashboards available. Those Grafana template will be available probably tomorrow also in the link control repo. And this is an example of the default JMX data that you can get. For example, the amount of used memory in gigabytes probably from the Puppetserver service, the amount of memory in the physical server. We don't have any swap configured. System load is quite low. The amount of memory heap that's used, CPU usage, also very important, open file descriptors. We noticed that when there is a huge amount of agents hitting the Puppetserver in parallel, you probably need to increase the amount of open files that Puppetserver can have. This is again, JMX data, just from a more active Puppetserver, so you can see it looks quite different. It uses way more memory, and also heap usage of memory looks quite different. And we have another screenshot from the actual Puppetserver metrics that you can get via JMX. And we have the amount of average so there are a few question marks here. We are not actually sure what kind of metrics we are displaying here. We are assuming it's the amount of compiled catalogs or something, but it's a bit unsure. There are so many metrics, as I said. So we need some time to figure out what we are actually displaying. And after that, we will open source the dashboards. But what we know for sure is average time spent for the find facts functions that's used quite often to call the PuppetDB to receive some data. Also the find node method, also used in the Puppet server to connect to the PuppetDB. And at the bottom we have some metrics about the amount of active HTTP connections, which were really helpful to debug the Puppet server. And the last that we have, the amount of free JRubies. Most of the time on this box we had instances available. The flat line at the top is the amount of available cores and the amount of maximum JRuby instances. So here it dropped down a bit because there was some agent hitting the box, and here probably someone pulled too often the metrics or restarted the Puppet server. So we have some data missing. And at the bottom we have a line about the average time that an agent had to wait to get a slot of free JRuby instances. In a perfect world, this would be a flat line at 0. So there are quite some peaks that we are still trying to improve, but those are values in milliseconds, so this is still quite okay. We did the same monitoring stuff back when we had only a single physical Puppet server and we had several minutes up to an hour for an agent to get a free JRuby instance, which is bad, very, very bad. Yeah. So very quick summary, scaling the Puppet server. It's a very complex and distributed system with a lot of services. It's a very bad approach to do all the improvements and afterwards implementing metrics and monitoring, and yeah, maybe you also want to implement backups. Yeah, you should probably implement it from the last slide back to the first one, and not the way we did this. And yeah, keep in mind, check out the control repo because it will contain all the examples that are shown here with proper acceptance and unit tests. Thank you.
Thank you. What version of PuppetDB are you actually running? Because I know for Puppet 5.2, Puppet actually advises against running Postgres 10.
Yeah, very important. So we are running latest 5. something. You get a warning that you're running Postgres 10. It's not officially supported. It will be supported in the next minor release of PuppetDB. That's the feedback that I got from Puppet Labs. But that's working, I don't know, since when. We installed Postgres 10 like 2 weeks after it got released. And since then we have 0 issues. You just get a warning that's not officially supported by Puppet Lab, but that's it. It works quite good.
Since we're talking about Postgres, do you have any experience enabling the parallel queries feature of the Postgres instance?
I think it's enabled by default on Postgres 10. I didn't know it exists. I didn't saw it in the changelog. Yeah, it works by default and it works quite good. We saw in the monitoring that the load went. The response time in the API of PuppetDB went down because the queries are executed faster. So that helps a lot. Yeah.
What I'm interested about, how many nodes have you running the Puppet agent on?
At the moment, 3,800, I think, and they're still checking the Puppet server each 15 minutes to 16 minutes, each 15 to 60 minutes.
Okay. So, thank you very much, Tim.
Yeah, thanks. Thank you.